All right, Jason Chamberlain, Senior Design Engineer at Specialized, and I've worked on all the demo platforms since the very first Demo 9 in 2004, and Demo 7, Demo 8, every generation until today. This is the new 2015 Demo with S3 size-specific sizing. Its full carbon chassis is nearly a pound lighter than the previous bike. It's got 650 wheels and 200 millimeters of travel. It's got a custom designed Öhlins shock and a reimagination of the FSR configuration that's both asymmetrical and concentric. And it'll be available January 2015. We'll be introducing 2 models of this full carbon bike at the high end, and then we will continue to keep the alloy bike as the base models, as you know it today, making just a switch to the 650 wheels. We consider this a very long-term project. About 2.5 years ago, I started putting my ideas down, and the goals were lighter weight, better bump performance, lower center of gravity, and those are kind of the original goals that I had to start with. So I started by thinking, what if we just moved everything down 3 inches? What would the bike look like? And naturally what happened was the main pivot moved into the same real estate as the bottom bracket. So it became natural just to integrate those into one pivot. Then I reconfigured all the other pivots around that. So the FSR 4-bar performance is still there, even though the pivots are in a radically different location. The first mule that we made was all cobbled together, mostly out of existing parts with just a few CNC parts. That was an effort to really find out if the pivots and the kinematics and all the suspension performance was going to be where we wanted it. So the key areas that we improved the momentum on this bike were reducing the unsprung mass by using a very light, narrow rear hub and a full carbon fiber rear triangle. That makes your rear suspension lighter, so it reacts very fast. We also have a partnership with Öhlins, where they tuned a shock specifically for this platform from day one. And of course, the introduction of 650 wheels helps to continue the momentum story. Wheel path is a big topic of interest in the bike industry. And at the onset of this project, we purchased every bike out there with every imaginable wheel path, so we could really understand. And what we found is that we could achieve the same level of performance through a properly tuned FSR with an Öhlins shock as you could with some of the radical designs with crazy wheel paths. When it comes to wheel size, we explored everything. We think for this platform today, 650 is the best because it gives you a balance of the lightweight and quick wheel response, and also allows you to package the rear wheel in a short chainstay. Going significantly bigger than 650 makes it almost impossible for your saddle to clear the tire at bottom out. There were a lot of great things about the old bike, and there are a number of things that we wanted to preserve. One was the chassis stiffness, or I would describe it more as chassis compliance, because we engineer in a specific amount of flex into the frame so that it'll track the terrain better. So with this new design, we targeted the same stiffness characteristics as the prior bike. We have many years of experience with wheel rate and leverage curves, and so we kept that in the same range as the old bike. It's just slightly more progressive at the end of the travel. When we brought Aaron on board, last year we did a lot of research into frame geometry, and ultimately we ended up with one single geometry that he felt fast on, but at the same time still honored the geometry that Troy had been winning on before that. So we have a bike now that is a longer chainstay by 10 millimeters than the previous Demo, which is still, for a 650 bike, probably one of the shortest chainstays out there. We also keep the low bottom bracket, which is very characteristic of Specialized bikes. We're introducing a new concept called style-specific sizing, or S3. Basically, you don't walk into a shop and buy a bike based on your height or your inseam anymore. You buy a bike based on how you want to ride. We offer 4 lengths of rider compartment. You can either buy up or down a size that you normally would. So now riders have the option to select the wheelbase and the front triangle and rider compartment that best suits their style. The pivot location is in a completely new configuration for Specialized and for FSR. And a lot of people have a tendency to fixate on just the location of one pivot, but really you have to look at all 4 pivots and all 4 bars. You can engineer the kinematic response based on the instant center, the movement of the instant center, and all the other variables to reach a pretty wide variety of performance results. So in this case, we're able to radically move the position of the pivots and still have the same braking, handling, and pedal characteristics as the traditional FSR. The plan for this bike was always to be carbon, 100%. There's a lot of reasons for that, one of them being packaging. You can make everything smaller and tighter, and you can make shapes in carbon that are much harder to achieve in aluminum. And also weight. Obviously with carbon you're able to reduce the weight dramatically and still retain the stiffness and function and strength that you want. Every location that has a wear item or a bearing or a headset has an aluminum sleeve inside for long-term durability. You may remember the old carbon demo used a rather large aluminum insert that slid through and was bonded in after the fact. Well, we have a new technology that allows us to mold the metal parts into the frame from the beginning in between the carbon walls. Those inserts are later machined after the fact, which gives you perfect bearing alignment and eliminates all the extra material that you don't need. Because the main pivot for the suspension is concentric with the bottom bracket, we had to get creative on how to package 4 bearings inside there. So we have a very large through axle that supports the chainstay, and inside that are the smaller 30mm bearings that are used on your standard BB30 setup. We're using a very advanced internal mandrel and bladder technique that allows us to make the inside surfaces very much as smooth as the outside surfaces. And the smoother and more accurate you can make your surfaces, the better the end product is. For the front triangle, we actually mold it in 2 pieces. When you break it down into smaller pieces, you have much better control over the fiber alignment and the compaction, and you're able to eliminate voids, and you have much better control over the end product. In addition to our world-class test lab in Morgan Hill, where we break thousands of frames a year, we also have a lot of other tools like ultrasonic scanning and X-ray that allows us to look inside the frames and make sure that we're able to get what we want out of the carbon. Specialized was one of the pioneers for 7-speed on downhill bikes, and we find that that works best with 135 rear width. If you look closely at the new axle, you'll find that it's keyed with a square pyramid shape on both the drive and non-drive side. That's an effort to tie together the left side seat stay and the right side seat stay, because right now where the pivots are, you don't have a bridge connecting the two over the top of the tire, so we tied the 2 stays together through the axle. One of the most striking features on the new design is the one-sided seat tube. With this new FSR layout, we realized that the upper portion of the seat tube structure only does one thing: it holds up your seat post. So we didn't need it to be as massive, and we didn't need the structure to straddle the shock like it had in the past. So you'll see an asymmetrical one-sided design, and that basically allows the frame to be packaged very tight and very narrow. It allows very easy access to the shock, and at the same time makes the construction simpler so we can provide a lighter weight package in the end. The fact that it's essentially one-dimensional now, the carbon mold can close without any complicated slides. It makes the frame easier to make. And when the frame is easier to make, it's easier to get the fiber alignment correct, which makes you require less of a safety margin in your design. So by making it a simpler structure, making it easier to make, there's weight advantages to be had, which ultimately makes a lighter bike for the customer. The shock link is a rather large structural component of the frame. It replaces about 1/3 of your seat stays. And because it's such a big part, it made sense to make it out of hollow carbon. There is an alloy part on the entry-level model. The carbon part on the higher-end models will save 240 grams over the alloy version.
My name is Brian Robinson, I'm a design engineer here. My involvement on this project was to design a link that was light, strong, also help manage the testing and support Jason with his engineering. So the differences between this link and the old link is this link carries a load of shock. So this is the highest stress member on the frame. So it's imperative that the strength is there and maintain stiffness, even though the seat stays are now separate. To address the strength issues of this link, we designed a link that's made from one piece. It's hollow in most places, and there are some key internal carbon ribs that add strength where needed. So the key function of this link is to transmit forces through all the bearings that are pressed in. And we didn't want to press the bearings into the carbon for reliability So we've designed aluminum in-molded parts that are mostly machined out. There's just a thin wall of aluminum that helps support the bearing and increases the strength.
Name is Jamie Stafford, a lead industrial designer on the new 2015 demo platform. Working together with the engineering team, we came up with a list of technical requirements, and my role as designer is to link all the pivots, the geometry, and skin it in a way that is absolutely beautiful. So once the pivot locations and geometry are established, the first step is always a ton of sketching, and so we went through hundreds and hundreds of sketch ideas and concepting and trying to figure out what this frame could look like, and then whittle it down to a few chosen directions. We take those, develop them a little bit further, we get them into CAD, we get them into the model shop, we play around with 3D models, we play around with pretty well anything we can to try and evolve the form and get inspired with what this frame could potentially look like. Once we have the direction chosen, then it really becomes a 3D development exercise. And diving into CAD is really where we do the primary aesthetic development on this frame. There's all kinds of ideas that we toss around, and there's a lot that never make it to see the light of day. But that's part of the development process, is we need to push the boundaries of where we're comfortable, explore all options, and then come back to things that are a little more real. Again, coming back to the design goals of this frame, we wanted this thing to look as clean and elegant and slick as possible, and we found that integrating the cables inside the frame is a very good way of doing that. We thought through the function of it as well. We know there are typically some internal cable routing solutions available on the market that are quite difficult to work on. Our solution here was we have a tube inside that all you need to do is fire the cable in the front end and it comes spitting out the back, so it's very easy for cable swaps. There's only one section of cable that is visible on the frame, and that's along the link, and there's hardly any movement of that cable, so there's no risk of damaging your frame or your cosmetics from cable rub or cable chafing. So one of the most important things, of course, is when you get into a carbon downhill bike is to protect your investment, and we thought everything out to offer areas of protection where they're a little bit more prone, and so we have a down tube protector that has it's a co-molded rubber and plastic part to dissipate impact. One of the goals, of course, was to keep it all sleek and integrated, and so it mates up with the frame perfectly and all the lines flow perfectly. But you'll see once you take a look at the inside of it that it actually has a standoff with rubber ribs on the inside of it to dissipate the chance of large impact.